Okay, well, let's just go out of this over there. So I'm going to slideshow. And yes, so we're ready to start now. So as I said before, the presentation that we're going to be doing today, well, the first one anyways, is going to be on food pyramids. So have you guys ever heard about the term food pyramids? Are you familiar with it?
Yes.
No.
Yes? Who said yes?
Me.
Who is me?
Jermaine.
Okay, Jumaine, what do you know about food pyramids?
Food pyramids, like they say that they're like the food chain.
Okay, yes, so they're very similar to the food chain, that's right. What else you know? All right, that's fine, that's fine. But that's good, you know something. So we're going to go into food pyramids. But before we go into what a food pyramid is, we're going to define a certain terms, and we're going to establish a couple of things first. The first thing we need to know is what is food. So this is any substance that is taken in by an organism that provides energy and nutritional value to sustain growth and repair. So I assume that everybody ate something this morning. They ate breakfast. So this morning I ate ham and toast bread. So what did everybody else eat?
Nothing.
You guys
I didn't
eat
get
nothing?
mine yet.
So somebody ate what?
I didn't get mine yet.
You don't get yours yet? So you're here
get-
No.
on an empty stomach. So
have
mommy and daddy didn't fix anything as yet.
No.
All right, in due time, man. In due time, you're going to get something. So, yeah, so food is anything that we intake into our body in order to provide us with energy. So, important key points. So, the thing that we have to know or pay attention to is that the sun is the ultimate source of energy for life on Earth. How many persons were aware of that?
Me.
Okay, all right. Okay, well, some persons were already aware. All living things require energy in the form of food, and organisms break down food by the process of respiration. The persons aren't familiar with respiration. It is that process in which we have glucose, and glucose that is in our body, which is practically our food, will combine with oxygen that we intake to break it down into carbon dioxide, water, and in order for us to get energy. So you guys are familiar with that before. You've heard about respiration. Yes? Our persons haven't never heard about respiration before.
I have.
The first time you're hearing this term?
No.
Okay, all right. So everybody is following so far. So in life, energy flows from one organism to the next. So plants have energy. They take energy from the sun, and when we eat plants or when other animals eat plants, they get that energy in turn. Energy is lost as it moves from organisms to the next, and we're going to go on to that and explain how energy exactly is lost. So next slide now. Hold on, there's this thing in the way. I'm going to try putting it at the bottom. Okay, so how do plants get energy from the sun? So the leaves of plants trap light energy from the sun and use it to make food in a process known as photosynthesis. How many persons know of photosynthesis? Or the first time you guys hearing that term?
No.
Okay, so you guys know what the equation for photosynthesis is like? Anybody knows the equation and can tell me?
Yeah.
Okay, what's the equation?
Sun plus water plus air.
Carbon dioxide in air, yes, gives us.
Photosynthesis.
The process is called photosynthesis, but yes, the end product that we get is
The
actually.
plants make their own food.
Yes. So the food that is produced is in the form of what we call glucose, right?
Sugar.
Yes, sugar. Yeah, that's the other name that we call the glucose. That's very good. Okay, so just making sure we're on track with time. So With the use of light energy, plants combine carbon dioxide, well, as you were saying before, in the air, which is present in the air, in order to give us water, with water. So they combine carbon dioxide with water with the help of light energy to produce oxygen and glucose. And as my friend was telling me that we also refer to glucose as sugar. So thank you so much for that. So here is actually what we have on the screen is an equation for respiration. So energy present in glucose is released through the process of respiration. So even though plants can actually produce their own food through the process of photosynthesis, sometimes persons aren't even aware that plants also respire, just like animals and humans do. So when these plants actually produce the food, which is the sugar, which is actually the glucose, they will then combine the glucose with oxygen in order to get energy. And the products that they get from that are actually carbon dioxide, which they actually release in the air, and water, which might be lost to the environment. So it says that this energy that was once trapped in the food is now available for use by another organism. Because plants are able to make their own food, they are termed producers. Everybody's following so far?
Yes,
Yes?
yes.
Okay, that's good. So plants both gain and lose energy. So it gains energy when it converts sunlight into food, which is the glucose. So that's where we get the energy from our food. However, it loses energy in the form of heat to the environment. Somebody said something in the chat. Oh, there's somebody in the break room that's unassigned. Hold on. All right. Okay, so sorry about that, guys, because sometimes persons might come up, so I need to make sure that I'm assigning persons at all times. So yes, as I was saying, that they will lose energy in the form of heat to the environment. And how that happens is like when it's really hot, like plants go through this process in which they sweat, but we don't call it sweating, we call it transpiration. So they will lose water to their leaves, and when they do that, they also lose heat to the environment. And when they do this, they lose some form of energy. Plants are also able to store the energy not being used in their tissues. So some of you guys might be worried that they might store the glucose in the form of starch until they're ready to use again. So next slide. Oh. So the energy possessed by plants can be passed on to another organism. Herbivores, which are organisms that only eat plants, gain this energy through eating the plants. So on the screen, you have some herbivores there. You have a rabbit, you have grasshopper, you have a cow. Anybody know any more herbivores that they want to tell me about? Any more animals that they know that eat only grass? Come on, guys, you must know of one.
I know a horse.
Yes, horse. What else? Anybody know anything else? Jumin said one. What else?
A goat.
Okay, goats. That's good. All right. So you guys know what herbivores are. So we've established that they are organisms that only eat plants. So we said a couple terms before. We talked about producers not too long ago. And what did I say producers were, guys?
They have produced energy.
Yes, and we said that plants are producers because they make their own food. So yes, everybody's following so far, so that's good. So moving on now. So animals such as lions and humans will feed on the herbivores and gain energy. So lions are carnivores, and what that means is that they only eat other animals. Anybody know of any more carnivores that they know of? Any more animals that they can name?
Tiger.
A what?
Tiger.
What? Good, Jumin. Jumin is on the ball. What else?
Jaguar.
Yes.
Panther.
All right, Jumin, thank you. Okay. All right, it says, meanwhile, humans and other animals, such as pigs, are known as omnivores. So they feed on both plants and animals. So that's so we know different terms now. So we know that herbivores eat only plants, carnivores eat other animals. They only eat other animals, and omnivores, such as humans and pigs, eat both animals and plants. So animals, in order to get food, must eat other animals or plants. They cannot produce their own food, and they are called consumers. So we know the difference, producers versus consumers. So producers make their own food, consumers must intake food. They cannot produce their own food. Remember that we cannot photosynthesize, so we can't produce our own food. Other animals cannot produce their own food, so we have to eat other things. We have to intake food in some form of way or manner in order for us to gain energy, for us to walk, jump, do all the things. I don't know what you guys do for fun, play PUBG, or I don't know. You guys play PUBG? I know that's what the my nephew is always talking about.
I play Roblox.
You play what?
Roblox.
Okay, that's good. I don't know what that is, but my little nephew is in the hall right now, and he's always talking about Free Fire and PUBG. So I know that's a game that a lot of persons and young persons tend to play. So moving on. So it says that it is important to note that animals like plants also lose energy. As you move from one organism to the next, less energy is available. This is because energy is lost as heat to the environment due to respiration, as well in the form of waste such as feces and urine. So what exactly happens is that when any form of organism actually intakes energy or gets energy, energy is lost, so that the energy that is going to be gained by the next organism in the food chain, they're getting less of that energy because less of it is available. Because remember that we excrete waste, we respire, we sweat, heat, so it's all lost as some form of waste to the environment. So we don't actually pass on 100% of the energy that we intake to another organisms, that is if they eat us, that is. We're talking about like animals. It's only really 10% of the energy is actually passed on. Most of it is lost. So we're going to now be talking about the flow of energy. So energy flows from one organism to the next, starting with plants, which are known as producers. So we have here we have a food chain, right? So we have the grass, and then the grasshopper eats the grass, and then another animal called the frog will eat the grasshopper, and then the eagle eats the frog. So a food chain is a diagram
Then
that shows what you were saying. Jomin, you're saying something?
the lion eats the eagle.
Yes. So, funny thing, I was just going to ask if you guys could come up with another food chain. What could help? What else could have eaten the grass?
The moo cow.
The what?
The moo cow.
The woo cow?
The cow.
The cow. And what could have eaten the cow?
The fox.
Well, yes, a fox could have eaten the cow. So we have another food chain. So we have grass, and then we have our rabbits. What could have eaten the rabbits?
The fox.
A fox could have eaten the rabbit. Even humans eat rabbits, so that could be possible too. You guys know that persons eat rabbits as well.
Chinese people.
Not just Chinese people. A few Jamaican persons eat rabbits. They have some jerk places that jerk rabbits. You guys weren't aware of that?
That's disgusting.
Yeah, so it's a thing in Jamaica. Persons actually, I know a couple persons who eat rabbits and jerk them and curry them. So you guys know, learn something today apart from you know that Jamaican persons eat rabbits.
They clearly have a strong.
Okay. All right. Okay, so let's move on. So by observing the food chain, the same one that was on the previous slide, we can conclude that the grasshopper is the producer, right? because it makes its own food, right? We all know that, right? The grasshopper, that's right, the grass is the producer, the grasshopper is the herbivore, and also what we call the primary consumer. You guys have an idea why it's called the primary consumer?
Because it's the first one that consumes.
Yes, thank you, because it's the first one that consumes. And the frog is called the carnivore, and it's called the secondary consumer because it's the second consumer in the food chain. And an eagle is a carnivore, and
Apex predator.
and it would be what consumer would it be, guys?
Apex predator.
Well, yes, it's the apex. Wow, we have persons know it. I'm glad that you guys know the term. So because the eagle is the predator, what would be its prey?
The frog.
The frog is its prey. So the eagle hunts the frog. So the eagle is the carnivore, it's the apex predator, and it's also the tertiary consumer in the case of this food chain. So I'm glad you guys are understanding and following so far. Everybody's on the same page, right? Everybody's following.
Yes.
Okay, that's great. Okay, so here it says in a food chain, we also have what is described as trophic levels. So trophic levels refer to the position where an organism occupies in a food chain. And here I have an example for you guys. My arrows are a little bit out of place here, but don't mind. So also another thing that I wanted to point out that you guys realize that in the food chains we always have, oh, somebody's putting in them for me, lovely. That we always have arrows in the case of the food chain, and this is to actually show the movement of energy. So you saw that the energy is moving from the seaweed to the small fish, from the small fish to the dolphin, to the whale. So if I had the arrow pointing from the small fish to the seaweed, I would actually be incorrect because it is a small fish that is eating the seaweed, so the energy is moving from the seaweed to the small fish. You guys understand that?
Yes.
Or do I need to repeat?
Yes, miss.
Okay, all right. Okay, Jumin says it understand. Everybody gets it, right? So the
Yes.
seaweed, okay, so the seaweed, which is the producer, is present at the first trophic level. And the reason why we said that this is the seaweed is present at the first trophic level is because this refers to the position to where an organism occupies. So because it is the first organism in the food chain, it occupies the first trophic level, right? So we have the small fish. Where is the small fish in the food chain? Which trophic level does it occupy?
Primary consumer.
Well, it's a primary consumer, but which position in the food chain it occupies? We're talking about trophic levels now. Where, which trophic level would it occupy?
Predator.
It would occupy the second trophic level. So let's go through again for you guys to understand. So when we're talking about trophic levels, it refers to the position to where an organism occupies in the food chain. So the first organism in the food chain is the first trophic level. The second organism in the food chain is at the second trophic level. The third organism is at the third, and so forth and so on. But I do like how you guys are able to identify that the small fish is the primary, is actually the primary consumer. And we could also say that the small fish is what? A carnivore or herbivore?
Herbivore.
A herbivore. So what would the dolphin be in this case? Would it be a carnivore or a herbivore?
Carnivore.
And what would we say about the whale?
Miss, whales don't eat dolphins.
Yes, you do have some whales that eat dolphins. You have
A whale.
we're actually going to be looking at a type of, well, it's not really a whale, but they call it, that's the name. But you do have some big whales that actually will eat dolphins, guys.
The orca, the killer whale.
Yes, they do eat. Yes, they do eat dolphins. So yes, so the whale would be at the 4th trophic level, the dolphin is the 3rd, the smallfish is the 2nd trophic level, and the seaweed is the 1st. Everybody is following so far, right?
Yes.
Okay, lovely.
Whales are carnivores.
So now, William, you said something?
I'm saying whales are carnivores.
Yeah, whales actually eat other organisms. They actually intake anything really.
Algae
Yes.
and shrimp and krill.
Yeah, that's yes, definitely. So food pyramids. So food pyramids are used to show the relationship between organisms. I have organisms, but organisms within a food chain. There are 3 types of pyramids we're going to be looking at. We have the pyramids of energy, the pyramids of number, and the pyramids of biomass. Have you ever heard about these terms before, guys?
No.
No?
No.
All right. Don't worry, we'll be going into them. So anybody have an idea of what they think the pyramid of energy is about?
The different producers and consumers.
Well, yes, the food pyramid is going to obviously involve the different consumers and the producers. But what do you think they're trying to show? What do you think they're trying to signify using the pyramid? All right, it's fine. We're going to show you right now then. So the pyramid of energy. So pyramid of energy shows the energy relationship between organisms at different trophic levels. It is used to indicate as we go higher in the food chain, less energy is available. So let me explain, guys. So remember how I was saying before that as you move from one organism to the next, less energy is available because you lose it to the environment, we excrete. So we only probably around 10% of the energy is actually given to the next organism that is in the food chain. You guys recall that, right?
Yes.
You guys recall, right?
Yes, I remember.
Okay, you remember. So say grass photosynthesizes and produces food, and after breaking down the food, it gets 10,000. In this case, it says kcal, but because you guys aren't familiar with that term, I'm going to use joules. So you guys have heard about joules before, right?
Yes.
That term, like using joules as energy, right? As the unit of energy.
Yes.
Yes or no?
Yes.
Yes.
No.
Okay. So it's just a unit of energy, like how would measure temperature in degrees Celsius or Kelvin, or how would measure length in meters. Joules or kcal is just a unit of energy. It's just how we measure it, right? So don't become too confused with it. Just pay more attention to the number and not the actual unit. So we're saying that a grass, right? It has 10,000. Hold on, guys. Natari. Oh, Natari are always coming, ending up out of the It's always ending out of the break room for some reason. I don't know. Okay, my bad, guys. I had to add somebody back. It says pyramid of energy. Yes, as I was saying. So we said that the grass, right? It has 10,000 joules or kcal of energy, right? And then the grasshopper eats it, right? Remember at one point, the grass is going to lose some of its energy to the environment and excrete, just like humans does, they just do it in different ways. And animals do as well. When the grasshopper actually eats the grass, it's only going to get 1,000 joules or kcal of energy, That's what it's going to be, it's actually going to gain because some of the energy is lost. The same thing happens when the frog eats the grasshopper. The grasshopper moves about, is exposed to the environment. So when the frog eats the grasshopper, it only actually gains 100 joules of energy, and so on and so forth with the snake and the hawk. So in that case, what we notice is that the snake, by the time you reach the hawk is only gaining 1 kcal of energy. Do you know that what that means? you would have to be eating like more than one snake. You'd probably have to eat like at least 5 or 6 snakes in order for it to become full, right? You understand what I'm saying? You guys are following?
Yes.
So what the importance of the pyramid per se is that it starts. Hold on, let me do the annotation thing so probably you guys will get it a little bit. So it starts off here at the bottom, right? And at the bottom of the pyramid, you realize that it is the biggest part, right? As in, you know, it's the fattest or biggest part of the pyramid, right? You guys are seeing that? And then you realize as you reach 2, it becomes smaller, 3, even smaller, 4, even smaller, at 5, it is the smallest. So this area right here to show that this has the smallest amount of energy and this would have the largest amount of energy. So it says that you go up the period, that's why it's called the pyramid of, not period, sorry, pyramid. As you go up the pyramid, there is less energy. That's why it's called a pyramid of energy. So it's showing that as you go along the food chain, there is less energy that is available. That's why the pyramid looks like that. That's why they call it the pyramid of energy. Okay, so we're gonna clear. Is who's trying to help me out? All right, so yes. So also I want to see if you guys can actually be able to tell me what trophic level is the frog at?
Trophic level 3.
Yes, it's trophic level 3. And it would be what consumer? Would it be the primary?
Secondary.
Yes, it's the secondary consumer because it's the second consumer. So it's, even though it's at trophic level 3, it is the secondary consumer. That's very good. As persons are following, persons see how that is the answer.
I don't see how that answer.
William, you see why it's trophic level 3 and secondary consumer?
I see why it's trophy number 3, but I don't know how it's second consumer.
Why is it trophic? Okay, so remember, let me just go back over. So remember what we're saying, and let me go back to this. Let me just go back to the side. That's what we're going for. Where was it? Hold on. I think I passed it. Yes, here it is. So it says trophic levels refer to the position where an organism occupies in the food chain. So the first organism in the food chain is at trophic level number 1. The second in the food chain is trophic level number 2. The third in the food chain is trophic level number 3. The fourth in the food chain is trophic level number 4, and so on and so forth. Remember that what I was saying before? So you just try to remember that term. And don't worry, guys, I'm going to be uploading this on the Google Classroom that you can have them to read. It just has been giving me a little bit of issue to be uploading some of the things because I'm trying to coordinate some of the other activities. But yes, so in this case, the frog is at the 3rd trophic level. The grasshopper would be at the 2nd trophic level. The grass is at the 1st trophic level. The snake is at the 4th trophic level because it's the 4th organism in the trophic. So we go, grass is number 1, grasshopper 2, the frog is 3, snake is 4, and the hawk is 5. So you're following now, William, what I was saying before?
Yes, I see.
All right. Okay, so we can move on to the next slide. So we're saying pyramid of numbers. So the pyramid of numbers, it's a little bit more tricky. So the pyramid of numbers is sometimes similar to the pyramid of energy. However, instead of showing the amount of energy present at each trophic level, it shows the number of organisms that could possibly be present at each level of the food chain, within a specific area. So whether it be in Kingston or in Westmoreland or somewhere, right? So, and let me see if I can hurry up and wrap up because it's almost 9:45. So say you have the pyramid of numbers, right? And here it says you have 100,000 leaves, right? They're saying when you have that 100,000 of these, 10,000 caterpillars will actually eat those 100,000 of these. But we actually have to think practically, you know, what really happens in nature. So then those 10,000 caterpillars are eaten by 100 blue tits, the 100 birds. And then those 100 birds might be actually eaten by that one hawk or eagle or something like that. I mean, obviously the hawk and eagle won't
Peregrine falcon.
yeah, they won't eat our falcon. They won't eat the all 100 at one time, but you can see where how the pyramid of numbers come into play, right? You guys are understanding?
Yes.
Yes, me.
So while the pyramid of numbers can look a lot like the pyramid of energy. Okay, hold on, guys. The Nika is supposed to go back into the I think the Nika is supposed.
Miss, you're on mute. I can't hear you.
I'm sorry, guys. I was trying to put back some persons who came out of the break rooms in the tropical forest. My bad. Yes. So as I was saying before that, pyramid of numbers can look a lot like pyramids of energy, and it can also look not look like it at all. So I'm going to go on to our next slide and show you guys what I'm talking about. So in this case, right, this pyramid kind of looks weird, right? You guys agree? It kind of looks weird. So yeah, it kind of looks a bit weird. So in this case, right, because the pyramid of numbers is really supposed to be actually showing the amount of organisms that could possibly eat at that point in time in a specific area, it sometimes might look odd, right? It might not look like a normal pyramid that you guys might say that starts big at the bottom and goes smaller towards the top. So in this case, it says, so you have 5 rose bushes, right? So you have some bushes. And those 5 rose bushes are eaten by, for example, 80 green flies. And those 80 green flies are then eaten by 15 ladybirds. And the 15 ladybirds are eaten by 7 spiders. What the pyramids of numbers, or why the width of the pyramids, the different sections of the pyramids look so different is because it's actually approximate
Miss?
to, yes?
Miss? Aren't flies bigger than ladybirds?
No, it's the pyramid of numbers isn't supposed to be an indication of how big the organisms is. It's supposed to be an indication of how many organisms are eating at that point in time. You understand?
Yes.
So okay, so if we have 5 rose bushes, right? Around the 80 green flies, or more or less really, will eat on those 5 rose bushes at one point in time, right? When those 80 green flies eat, so when we have with the size of it, the size of the pyramid, hold on, I'm going back. I don't see it, so John. The size of this, right, is supposed to show that it is 80 green flies here. So it's not supposed to show that show that the green flies are bigger. It's supposed to show that it is 80. Thank you, right? And then the rose bush, the size of the rose bush is supposed to show that it is 5. 5 there. And then for the ladybirds, right, you realize that the block for the ladybirds is smaller, so it's supposed to show that it's actually 15 of them there, right? It's 15. So 15 ladybirds will eat around 80 of the green flies, so they'll share them up in some way or some form, right? And then those 15 ladybirds are eaten by around 7 spiders, right? So you can see that the size of each block is actually proportional to the number. It's actually proportional to the number of organisms that are eating at that point in time, not the actual size of the organisms. Everybody is following?
Yeah.
Yes? You're following, William?
Yes, miss.
Okay. All right, that's good. So let me clear this off right now.
Following.
All right, and then the last one, because I want to finish up, is the pyramid of biomass, right? This one might be a little bit more technical for persons to understand. It's 9:45. The pyramid of biomass estimates the dry weight of organisms present at each trophic level at a specific time. So what this means when we're talking about the dry weight is that practically when these organisms are dead, right, and we take out all the water that is present in those organisms, it is actually just supposed to show that the mass of those organisms, when all the water is taken out of it, is actually what will give us the pyramid of biomass, right? So the grass would look like the typical, so the pyramid of biomass always looks like the typical pyramid, where it's big at the bottom and smaller going up to the top. So the biomass of the grass will be much more bigger than that of the rabbit. That of the rabbit will be much more larger than that of the fox, and that of the fox will be much more larger than that of the wolf. Persons are following?
Yes, miss.
Okay, that's good. That's good. Because so it says organisms are collected from each trophic level. They're dried and then weighed. The dry weight indicates the amount of organic or natural substances or matter of the organisms. And look at food safety, and let me see if I can hurry and finish, because this is a really quick one. So it says food safety refers to handling, preparing, and storing food in a way to best reduce the risk of individuals to becoming sick from foodborne illnesses.
Yes.
The principles, yes, Jumin?
Are we going to do another word, sir?
Pardon?
Are we going to do another word, sir?
Not in this activity,
No.
but in one of the incoming activities, we're going to be doing one, hopefully. So it says to reduce the risk of individuals becoming sick from foodborne illnesses. So the principles of food safety aim to prevent food from becoming contaminated, which can lead to food poisoning, right? So we don't want to become sick when we eat our chicken or pork or seafood. I don't know what you guys like to eat. So we have to be able to handle our food in a safe way, right? So there are food safety rules, right? What they call the 4 C's, and they're called cleaning, cooking, cross-contamination, which is the prevention of cross-contamination. And we're going to go into defining all of these and chilling, right? So let's look at them now. So cleaning, right? So when preparing food, always ensure to wash hands and utensils as well as the cutting board. So surfaces should be wiped down properly with a disinfectant. Fruits and vegetables must be washed with water, and poultry and other forms of meat should be cleaned and washed roughly with vinegar. So how many persons ever actually cooked chicken or helped their parents in the kitchen before? Or see what their parents do when they're cooking? All right, that's great. And before they start cooking, like this, when they start cooking their chicken, you see that they wash it off with vinegar and they clean it out, and when they're finished, they wipe down the counter with like some bleach, right?
Yes, miss.
Yes, and that is the cleaning process in when we're trying to properly handle food. So we don't want to get any form of cross contamination or anything like that. Okay, hold on. One moment, guys. All right, guys, sorry about that. So we're saying yes. So we'll always see our parents and do that, and that is a process of helping to handle our food properly in order so we don't get sick or anything. So the next process is, it's not changing. Okay, cooking, right? So once food preparation has taken place, so once we have cleaned up the food and wiped down our surfaces, we have to cook the food now, right? So in order to do so, we must carefully look at the instructions for different food items now. And always read the instructions on the packaging, right? So we know that different forms of meat take longer to cook. So like pork is a meat that takes really long to cook, and if you don't cook it properly, it can get sick. You know, if you're cooking curry chicken, you have to burn the curry properly, or you can get diarrhea. So we know that when we're cooking properly, when we want to cook properly, we need to follow the instructions in order so we don't get sick, right? So food has to be cooked at the right temperature in order to kill germs that can possibly make you sick. So the meat has to be cooked at a certain temperature for a specific period of time in order to kill any germs that might possibly be on the food, right? And next thing, we're finishing up quickly, we're soon finished, is cross-contamination. So what we want to do when we're preparing our food is actually prevent cross-contamination. So what is cross-contamination? Cross-contamination is the transfer of germs from one food item to another. So in order to prevent this, we must use the method of separation. So if you ever see that your parents or somebody who is cooking in the kitchen, you realize that when they're cutting up the knife or the cutting board that they use to cut up the chicken and clean out the chicken or any part of or any form of meat, they don't use that same dirty knife or cutting board to cut up the vegetables. And why they don't do that? Jumin, you want to give me the answer?
It's because it,
Yes, no, give me Abriana.
it's because it is germs.
Yes, they don't want the germs to go onto the vegetables. They don't want to cross-contaminate. They don't want to transfer the germs from one food item to the next. So you make sure at all times you use separate cutting boards for like poultry, seafood, and vegetables. So if you clean out your chicken with a knife or you use a cutting board, you don't use that same cutting board, or you have to wash it off before you use it. So we ensure that when we're shopping also that we store or keep certain types of food separate, for example, eggs, seafood, and pork. Also, properly washed hands and utensils can help to reduce the spread of germs to our foods. So next one is chilling, right? I think everybody is familiar with this one. So this is a good food safety also requires that food is stored properly. So when we buy our meat, right, we put them in the freezer, right? You guys will recall anytime you probably go grocery shopping with your parents, the first thing that they probably do is take out the meat out of the bags and they put it in the freezer, right? Because they don't want it to spoil, right? Yes or no, guys?
Yes, yes.
Yes, because
Yes,
they don't
yes.
want it to spoil. So in order to safely store food for a prolonged period of time, somebody was saying something, you wanted to add something?
I was saying yes.
Yeah. Yeah, so in order to safely store food for a prolonged period of time, the temperature of refrigerator should be set to 40 degrees Fahrenheit or below, and the freezer at 0 degrees Fahrenheit. So food should never be allowed to thaw out on the counter. So guys, if your parents thaw out the food, like when they're going to cook their Sunday dinner, and they're going to cook their chicken or their mutton or their beef, and you see that they take out the meat and they put it on the counter to thaw out, tell them that they're not supposed to do that. The proper way, the safest way to thaw out meat is to actually put it in the refrigerator, right? Because there can be harmful germs that will actually start to grow when you put it on the counter. So it should be noted that freezing, and it doesn't show, but you guys will see it. It should be noted that freezing does not kill harmful germs. So if you do have contaminated meat, guys, and you put it in the freezing is not going to kill the germs. All it simply does is slow down the growth of those type of bacteria or germs that are present. So I hope everybody understands, everybody is following, and this is the end of the lecture. So you guys can clap or whatever. So that's good. So I hope everybody follow. I'm going to put up an assignment or just a little quiz on food safety and food pyramid, just to give you guys, in order to make sure that everybody actually understand and follow what is going on. So William, you had a question for me? I see you're unmuting your mic.
No, you told us to clap, so I was clapping.
Oh, great. All right. Thank you. All right. So you're supposed to have your next presenter now. So just give me a few minutes. I'm going to see if she's here.